minus 25. X squared is equal to 75. So applying the square root principle from this point, you get x is equal to the positive or negative square root of 75. Okay, x is equal to the positive or negative square root of 25 times the square root of 3. X is equal to the positive or negative 5 by the square root of 3. And of course we're going to use a positive value because it can't be negative. Now we're calculating 5 square roots of 3. Okay, we get 8.6602. Or but you can say 8.66. Okay. Now we found our height. Okay? Or x. Which is 8.66. Now that we found this, we can find the area for both one of the right triangles from it or the entire equilateral triangle. So here, for calculating the area for our entire triangle, the area is the base of this entire triangle, which is 10, okay? Say this base times its height, okay? Which is x. You go 10 times 8.66 over 2. Okay, so that becomes 86.6 over 2. Okay, or 43.3. Okay. Three units squared. Okay. Now that's the area of this entire triangle. If you want to calculate the area of half of it, which would be this right triangle, okay, its base is half of the other triangle's base, but it has the same height and the same in this other dimension here. But you don't have to but you don't focus on the hypotenuse of a triangle for it to calculate its area. Only the base and the height. In which case here, its base is 5 times 8.66 over 2. In which case that's going to come out to half of this. Okay, so that's going to be so 5 times 8.66 divided by 2 is 21.65 square units. So I'll show you this, and if you're working on a problem, we got to calculate the area of a triangle, and then you cut it into 2 right triangles. Don't forget, if you calculate the area for just the right triangle, you have to multiply that value by 2 in order to get the value for the entire triangle. Okay, now I want to talk about right triangle methods with scalene triangles or oblique triangles. Okay, now how we do this? Okay, if we want to find, let's say we want to find the length of one of these sides, and we don't know the other, or we want to find the area. Let's say we want to calculate the area. Okay, if you want to calculate the area, remember the area of a triangle is 1/2 base times the height, and that's because if I take a square, you can say B and H, but B and H could be the same, and if I divide it in 2, I get a right triangle. I get 2 right triangles, and this formula tells me the area of that. Okay, now but this for a right triangle. Okay, now if we have a now here, this is not a right triangle. Okay, so we have to calculate the area according to what we know about a right triangle. That's what we're focused on now, right triangles. So some has been taught to draw your height this way, or this would be your height, and then work on methods that way. I'm not even going to teach you that way because it's confusing. Because to calculate the area, remember the area equals base times height divided by 2. So after drawing a height, which line are you going to use as your base? And then see, if you use this entire line here as the base, you're going to get the area for a right triangle with this area added. But that's not what we're looking for. We're looking for this area inside here of this scalene triangle. So would you use this as the base, this portion here? Or would you use even the longest part as the base? You see, this is confusion. So I like to teach a different method, and I use a different method. A right triangle method. Okay? In this case, what I do is we turn it into 2. You go towards the widest angle. This here is the widest angle, okay? So you start from the widest angle. Draw a height or altitude from the widest angle to the longest side. Perpendicularly. Okay, so that it meets it at a right angle. Okay, so here we have two right triangles now.